Good morning, class. This is Dr. Cheng Yao Lin. Today, we're going to learn about integer multiplication. And in this video, we will talk about how to explain why a negative and times a negative equal a positive. So we have to explain the reason behind, not just giving a student a rule, okay? So we have several different models we can discuss. Negative, why negative times negative equal positive. The first one is a pattern model. The second one is a number line model. And the third one, I'm gonna introduce German method. And let's start with the pattern model. Okay, so pattern model, first of all, we have to answer why a negative times a negative 1 is equal positive 1. So we have to answer this question. And we can use the pattern model to explain this, okay? So before students learn integer like a negative, and then they already know like a 3 times 2 is equal how many? This is all connected to their previous knowledge, which is equal 6. Now 3 times 1 is equal 3. 3 times 0 is equal 0, right? So did you see the pattern here? This is a what? Decrease by 3. This is a decrease by 3. Is that right? So what about next one? If I take a 3 times a negative 1, what will be the answer? The answer will be negative, how many? Negative 3, right? Now what about 3 times negative 2? 3 negative 2, so decrease by 3, decrease by 3 again, so this one has to fill in negative 6, all right? So that's the pattern. Did you see the pattern? We can explain. So now we can move on to next. So student know 3 times negative 2, which is equal negative 6 in the beginning. Is that right? All right. So now if I have 2 times negative 2, which is equal how many? Negative 4. Is that right? So here we actually is increased by 2, right? Increased by 2. So now what's next? Next will be 1 times negative 2. 1 times negative 2, which is equal negative 2. Is that right? So now again, here is increased by 2, right? So 3, 2, 1. Next one is 0, right? So 0 times negative 2 is equal how many? Is equal 0, because increased by 2 again. All right, now the next question is, we have 3, have 2, and 1, and 0. And the next one will be negative 1, right? So now we have a negative 1 and negative 2, negative times negative, which is equal how many? Is equal a positive 2. Did you see the pattern? Because we increased by 2. The pattern, did you see? We increased by 2, right? So another negative times a negative, you can answer this. So negative 2 times a negative 2, oh, therefore is a positive 4, because increased by 2 again, right? So this is a pattern model, okay? Pattern model is very simple and easy way to explain why a negative times a negative equal a positive, okay? Now, next, I want to talk about number line model. Number line model. Now, number line model here, we have, let's say we have 50 times 3, all right? 50 times 3, which is 150, right? So here I want to rewrite this is a positive 50 times a positive 3, right? And again, number line, and to think about the number line like this, all right? And I'm gonna 50, 100, 150, and this is a negative 50, this is negative 100, and so on, okay? So here, 50 times 3, then I can give like a telling a story. Now telling a story about what? I'm driving a car, right? Driving a car. Now driving a car start from 0. Driving a car start from 0 here, okay? And this is eastbound, this is westbound, okay? Now eastbound, westbound. Driving a car 50 miles per hour. 50 miles per hour. Now 3, we can say 3 hours, all right? 3 hours from where? From 0 actually is from now, all right? So now, okay? I'm gonna change the color. That will be help you to see, okay? Change the colors, 3 hours from now, 0 is now, right? Now 3 hours from now, where is the car? Well, 3 hours from now, I'm driving the car right now. Now 3 hours, you know, from now. So 3 hours, that's the 1 hour, which is 50 miles, right? Where? To the eastbound, okay? 2 hours. So 1 hour, 2 hours, and then 3 hours, right? 3 hours from now is right here. So the car, the location is right here, 150 miles, right? To the original, compared to the original location, where is, what's the 150 means, okay? So we can explain this, you know, to children, you know, 50 times 3 actually, you know, by using a number line like this. Now next, clear everything. I'm gonna change it is into what? I'm gonna change this into 50 times negative 3, all right? So 15 times negative 3, how can we explain this? Again, I can use the number line like this, right? And then here is my 0, 50, just one more time, sorry. 50 times the negative 3. Okay, now this is a 50 times the negative 3. So again, I'm gonna tell you a story. I'm driving a car 50 miles per hour, right? Now negative 3 here, negative 3 means 3 hours ago. So where is the location of a car 3 hours ago? Driving a car 3 hours ago, where is the location, right? So here we can say 0, right? This is negative 50, this is negative 100, negative 150, this is a 50, 100 there. So we know the answer negative 150, is that right? So here, I'm gonna change the color, all right? Now here is a car. Now is a 0, right? Now, 50 miles per hour, 3 hours ago. So where is the car 3 hours ago? 1 hour ago. 2 hours ago. 3 hours ago. Now where is the car? What was the car 3 hours ago? Negative 150. So we can explain this 50 times the negative 3, which is negative 150. Oh, don't forget, this is eastbound and this is the westbound, right? So the car, look, 3 hours ago is right there, right? Does it make sense to you? Okay. Now, next, we're gonna have negative 50 times 3. And how do we explain this? How do we explain this? This time we have negative 50, all right? So now again here is a 0, 50, 100, negative 50, negative 100, negative 150, right? So again, we still get the answer 100 and negative 150, right? And what does this mean? What does this mean? And how can we tell the story? Again, here we have eastbound, we have westbound, right? Now, in this example here, we have a negative 50 times 3. So what's the negative 50 mean? Negative means now we are moving to westbound. So the car, look, tall like this way, right? Tall westbound. If the eastbound, the car will like this, right? But if the westbound, we're facing westbound like this. So that means moving a car to the westbound 50 miles per hour, and then 3 hours. Again, 0 is from now, right? So now 1 hour, 2 hours, and 3 hours. Oh, where's the car? The car is right here, right? So 150, right? 150. So 1 hour ago, 2 hours ago, not ago. 1 hour from now, 1 or 2 hours from now, 3 hours from now. Okay. Ago is kind of backward, right? But for now, which is moving forward. Okay. Now here is another example. Now here we're gonna move into negative times negative, right? This is the answer we want to find out. Why a negative times a negative is equal or positive on the number line. So now we have 0, 50, 100, and 150. So procedurally, when we just do the procedurally is negative times a negative is a positive 150, right? And how do we explain this? With a number line, using a number line, explain this to children, okay? Again, here, don't forget, we have eastbound, we have westbound for this, all right? So now, where's the car? Car is because, right, driving a car to the westbound. That means the westbound, moving westbound, moving west, all right? 50 miles per hour. And then what's this mean? 3 hours ago. All right, okay, 3 hours ago. So driving a car westbound, 50 miles per hour, 3 hours ago. So where is the location? So everything start with the 0 here. Okay, why we facing this? Because of westbound, right? And then because this is a negative sign, so facing this, right? So are we ready to count? 3 hours ago, 1 hour ago right here, 2 hours ago right here, 3 hours ago right here. So that's why we have a negative and not positive 150. So 3 hours ago, 1 hour ago, 2 hours ago, 3 hours ago. Yes. Where is the location of the car? 150. So that's why that's why we say this is a positive 150. Okay. All right. So that's the number line. And next, I want to talk about German method and how the German classroom, they explain negative times a negative is equal a positive to children, okay? They are not doing just, just procedurally, by memorization. They're doing but more reasoning. Why this is happen, okay? So let's do German method, okay? The German method here, we're gonna do the multiplication, German multiplication, 12 times 11. If you have my 120, and we learn German method, right? In our 120, we learn German method. So we learned German method in 120 before, right? So 12 times 11, and actually I can decompose 10 and 2, right? Decompose 11 is 10 and 11, is that right? And we put on a box like this. Remember that in the 220 we talked about this before. So 12, this is a 12, this is the 11, right? So 12 actually is a 10. This put on 12, this put on 11, okay? 12 actually is a 10 plus 2. Is that right? Now how about 11? 11 is a 10 plus 1. Is that right? Now, in German classroom, they use the table like this. So 12 times 11 is like this, or like this setting, okay? 12 times 11. So therefore, we have break it down 12 as 10 and 2, break it down 11 and 10 and 1, right? So now we fill in the partial product in the box, okay? So 10 times 10, 100. 10 times 2, 20. 10 times 1, 10. 2 times 1, which is equal to, right? This is a partial product. So we added up the total. We added up the total like this way. 100 plus 20, 120, plus 10, 130, plus 2, 132. Final answer and 132. So this is the German method and how they do the multiplication like this, right? So now, what about how do we answer the question y negative times negative equal a positive, okay? Positive 1. And we can use the German method to answer, okay? So now, we have to connect to children's previous knowledge, all right? So before they learn negative times negative equal positive, do they know the multiplication table? Yes. Do they know 9 times 9 is equal how many? This is all their previous knowledge, which is equal 81, okay? Right, which is equal 81. So now you can think about 9. 9 actually is what? Is a 10 and -1. Is that make sense to you? Another 9 is a 10 and -1. Is that right? So we're gonna put in a box like this. 9 times 9 actually is final answer is equal 81. Is that right? Yes. So 9 actually is a what number put together? We decompose this, so that would be 10 and -1. Is that right? And then we put on the 10 and -1. Is that right? Okay. So next, we're gonna fill in the table like this. 10 times 10, how many? Would be 100. 10 times -1, which is -10. All right. 10 times -1, how many? -10. All right, now we're gonna put a question mark here because negative times negative is equal how many? We don't know, but we have to find it out, okay? So adding out the partial product, 100 plus -10 plus another -10, oh, plus a question mark, which is equal what? Negative times a negative, right? And then do we know the final answer? Final answer here, which is 81, right? So 81 for this, right? Because 9 times 9 is equal 81. So actually this is 9 times 9, right? All right, so now 9 times 9 is equal how many? All right, so here we kind of add together 100 plus -10 plus -10, which is equal 80. 80 plus one number will be equal 81. So this number, the question mark here, has to be +1. Does it make sense to you? So that's why we can using the German method explain why a negative times a negative equal a positive. Okay. Now, let's move on here. Some of the property I need to go over. Property integer application. For every integer a, you take a negative a1 times a, which is equal negative a. For all integer a and b, negative a times b, which is equal negative ab. Okay. Now we have negative a times negative b, which is equal ab. Okay, now we answer the question why negative times negative positive, right? We can use 3 different models to explain why negative times equal why negative times negative equal positive. Okay. For any integer a, b, and c, all right. So a times the parenthesis b minus c. So we have ab minus ac. Okay. And then we have parenthesis b minus c times a, which is ba times ca. So this is pretty much like a distributive property, right? The distributive property like this. We take a times b, got ab, a times c times ac, a times b times ab, ba, b times a times c times ca. Okay, like this. Okay. Now here is some of a problem we can practice together. -2 times -3. Now here is what? Negative times a negative. So therefore, this is a +6, right? Good. Now what about next one? The next one, can we just do the discrete property? Yes. Two ways we can do. One way we can simply do it, just take a 3, and 2 minus 1 is 1. So therefore the answer is a 3, right? Okay, that's one way we can do. What's the other way we can do? We can do the distributive property like this. 3 times 2, got a 6. Minus 3 times 1, which equals 3. So the answer is equal 3, right? Okay. Similar for this one, all right? 2 minus 1, two way we can do. Number one method, you can just, 2 minus 1, which is equal 1. And times 3, so answer is a 3, okay? Number two, can do the discrete property. We take a 3 times 2 is equal 6. Minus 3 times 1 is equal 3. So the answer is 3. See, they have the same answer, right? Okay, two different ways we can do. Now, the next one, integer operation. So here, it's pretty much like a distributive property we can do for this problem. So you want to make sure everyone have, let's do the multiplication here. So this times this times this, all right? I'll give it another color. Green go to green, blue go to blue, okay? So now discrete property, okay? Let's do -4 times -4, which with -4 negative -4, which is equal 16, right? So this is a 16, right? And next, another blue, -4 times the negative b, which is 4b, okay? Then next, I wanna do green. -4, you take a -4 times of b, which is -4b, right? And next, you have b, negative b and positive b, which is a negative b squared, right? Now here, I'm gonna add together, which one we can cancel. Oh, this one we can cancel because it's positive, negative. So 16 minus b squared. Now pass. 16 minus b squared, okay? So that is the how we solve for this problem, okay? Next problem, a minus b times a minus b, all right? A minus b times a minus b, okay? Now again, I'm gonna use a two different color. One is red, all right? A times a times negative b, and the other one, negative b here is actually negative b times negative b, okay? So let's do it. A times a, how many? That's a squared, right? A times negative b, how many? Negative ab, is that right? Good. Next, negative b times a equal how many? Negative ba, and actually you will just write negative ab, okay? Next, negative b times the negative b, which is equal positive b squared, right? So, make sure, the integer operation multiplication is correct. So now, final answer is a squared minus combine together 2ab plus b squared. That would be our final answer for this, okay? All right, see what's next. Next, we're gonna talk about integer division. If a and b are any integer with a b not equal 0, then a divided by b is a unique integer c if it exists such that a equal b, c, all right? So, a divided by b equals c, and then if we want to find out what's a actually is what? All right, a actually is b, c, okay? All right. So here we have a problem here. Okay, 12 divided by -4. So 12 divided by -4. Procedurally, how we do this? We have 12 over -4, right? So 12 over -4. Actually, here we have, when we divide it by a -4, you know, we don't actually, you know, actually we usually put on denominator as a positive, okay? So we usually write like this, -12 over 4. So actually it's a -3, okay? Now what about -12 divided by 4, which is -12 over 4, again, -3, yes. Now here, -12 divided by -4, which is equal -12 over -4, which is equal 3, okay? So a negative divided negative equal positive, right? So now I want to give you an example to show the integer division, okay? Here is a pattern model we can show to you. For example, 4 divided by -2, right, is equal how many? And we can show the pattern model. So here, we're gonna start with what? Start with 0 divided by -2. 0 divided by -2, how many? 0. Next, 1 divided by -2, how many? -1/2. 2 divided by -2, how many? -1. Okay, now, pattern. Did you see the pattern here? We decrease by 1/2. Decrease by 1/2, right? Now, what about 3 divided by -2? Divided by -2, which is decrease another 1/2. So we can fill in this is -3 over 2, right? -3 over 2. So therefore, 4 divided by -2, which is equal -4 over 2, which is equal -2, right? So that's the one example I can show you for the pattern model. Now, what about if I want to say -2 divided by -1 is equal how many? Can I show the pattern model? Yes. I know 0 divided by -1 is equal 0. I know 1 divided by -1, which is equal -1. So here is a pattern, right? You can create a pattern. This is a decrease or increase. This is decrease by 1. Now decrease by 1, so here is 2 divided by -1. We have to fill in how many? -2, okay? Because this is a decrease by 1, okay? All right, so here is the integer multiplication and division. And thanks for watching, and I hope you enjoy this video. If you have any questions regarding any models, and you can send me an email and I will answer you. Thank you. Have a good day.